Hello, my name is Gordon Whitlock. I'm with Glow Research. Today we're going to talk about the Glow Research OptiGlow ACE system, which we have right here. It's actually running plasma as we speak. We're going to go through the system, show you how to process samples, how to start the system, and how to hook the system up. So thank you very much for your interest in Glow Research and the OptiGlow ACE. Please feel free to give us a call, or you can go to our website at www.glowresearch.org. What you're seeing is a picture of the OptiGlow ACE system. Right here we have 2 flow meters with the system. Typically we like to operate those at mid-range. The pressure envelope that you want to operate your system is anywhere from around 0.5 to 1 torr. The system will typically strike a plasma at about 0.3 torr. The pressure will rise up, so once again the pressure envelope is around 0.5 to 1 torr. Down here we have a timer that you can put your time in for up to about 999 minutes. Most people, of course, don't need that long of a time period. Here's the on-off switch. This is the vacuum switch that opens and closes the vacuum valve. And this switch right here turns the process on by virtue of the automatic tuning. The OptiGlow ACE system has automatic tuning by merely depressing the switch. When the system hits 0.3 torr, it will automatically ignite a plasma. You'll see this selector knob right here. On the very bottom setting, it will give you a pressure output right here. In a moment we'll go through this and we'll actually strike a plasma, and you'll see that. But the very bottom setting will give you a pressure reading right here. It typically starts out about 1.6 torr and will strike a plasma at 0.3 torr. It has a piranha gauge in the system, so you get a very accurate measure of your process pressure. The next selector is the amount of watts that you're putting into the system. You can typically put in anywhere from around 15 to 150 watts. The next selector gives you the reflected power, and this reading is typically extremely low in the OptiGlow ACE system. The final reading tells you the exact amount of RF power in wattage that's going into the plasma. So you set your power down here, and then you come back to the very top setting. It gives you the actual amount of power that's actually going into the chamber. And now we have the chamber door, and you'll see that the chamber door has a dynamic offset right here, so that when it pushes against the chamber, it actually pulls the chamber in to increase the vacuum integrity, thus lowering the chances of any vacuum leaks in the system. We have a Viewport door here, and it has a sight glass that's been specially treated to filter out UV radiation. Opening the door, you'll see that there's a O-ring on this side right here that provides the vacuum integrity and the seal against this door right here. The chamber is an anodized aluminum chamber. It's been specially anodized to handle gases such as CF4 or other fluorine-based chemistries. The wafer sample holder or the sample holder slides out, or you can put it in. So if you put samples on the top electrode, you'll be in a RIE configuration, reactive ion etching configuration. Or if you put your samples on the bottom shelf, you'll be operating in a plasma condition. Some people like to put their samples up here to have increased power, increased bombardment. Other people like to put their samples here for more of a plasma or more of a chemical type of a process. This sample so you want to firmly put your wafer sample holder or your sample holder firmly into the system. It'll slide into the back 2 electrodes. Once it's in, make sure that you can close the door. If you can't close the door, it's not in correctly and you will not ignite a plasma. Put it in, close the door. There's a magnetic switch right down here that holds the door closed. And then when you push the vacuum button here, it will pull the chamber door in. What you see is the side and the back of the OptiGlow ACE system. you'll see that right here, air flows into the side of the system. We have a similar vent on the very opposite side of the system. You want to make sure that you don't block that vent. Air flows through here across the electronics, keeping them cool, and out the very back of the system right here. On the very back of the Glow Research OptiGlow ACE system, you'll see there's an inlet for two different gases. The pressure coming in should be regulated to about 10 psi. Right down here you'll see that there's a breaker. This breaker must be in the up position for the system to work. Right here is your AC connection for your electricity. And right here is the KF25 connection to the vacuum hose. You want to make sure you have a clamp on and it's properly fitted with a KF25 flange. Once again, right here is airflow coming back out of the system. So we're going to go ahead and start the system up, and so we're going to assume that you've put your samples either on the bottom shelf for plasma processing or on the top shelf for more of an RAE style processing. And you've shut the door and it latches shut right here. We're going to go ahead and start the system. You'll hear a sound. That sound is the fan going through the system and also the arc generator. If I open the door, that sound will diminish and go off. Right here is a breaker switch. This breaker switch must be closed for the system to operate. We also have other interconnects on the system. That means that the system must be fully assembled, the sides must be on the system for the system to operate and to meet all the safety criteria. Samples in, so once again you close your door. There's a magnetic switch right here that allows the system to start operating. We have it in the on position, and now we're going to press the vacuum to open up the vacuum valve, thus allowing the system to pump down. You'll notice that as soon as I press this button, it's sucked in the chamber. So now we're going to go over to pressure. You notice the pressure will start to pump down in just a moment. We have a Pirani gauge, so it's a very accurate measure of the chamber pressure itself. So as we start to pump down, I'll go ahead and push this button over here. When this gets down to about 0.3 torr, it should ignite the plasma. You can see there, it ignites the plasma. We have a pressure reading, it comes back up again. We have a power reading of 100 watts, and we have reflected power of, in this case, 0.6, 0.5, it should go down a little bit. And the actual power going to the system is 101, so it's very, very close to where we set it at. Well, it's actually 101, and the actual power going in is 101. The reflected power in this case, this varies between, looks like it's about 0.4 right now. And then we can either increase the power or decrease the power right here. To stop the process, you hit abort. You'll notice that as we start up again, you'll notice that these indicator lights will come on, indicating various different sequences in the process. This is a very valuable tool to have as we confirm that all the sub-modules are operating. Should you have a problem with our system, the arc generator, the match network, and various other components are all modular. Very easy to replace. So I'm going to go ahead and abort the process or stop the process right now. There, I've stopped the process. And over a period of time, after I press this button, the process pressure will come up, allowing me to open the door. Okay, so we've aborted the process, and we're going to start the process again. This time we have the system, the AC is on, so let's go over here. We'll check our pressure. Obviously it's very high pressure because the door is open, but we'll go to power, and let's take the power. Let's go down to a low power rating of say 15 watts. So we're gonna ignite the plasma at 15 watts. One of the nice things about our systems is that you can have a very low power or higher power. Notice that the fan will come on, and then we press this button here, pulling the door closed with a dynamic offset on the door right here. And so we're going to set the power at 0.15 or 15 watts. I'm sorry, set the power at 15 watts. The pressure should be coming down there. It's coming down right now. So we'll press the process start button. when it reaches 0.3 torr, or in that range, it should ignite the plasma. And there, ignite the plasma at a very low wattage of 15 watts. And once again, we'll read our reflector power at 0.3. Actual power going in is 16 watts. So we set it at 15 watts. Actual amount of power going in is 16 watts, is very good. Reflector power 0.3, also extremely good. And there's our pressure right here. You can control your pressure inside your system by the flow of gas. You notice that both of these flow meters are open and the bubble is about halfway. So you'll notice, let me turn over to the power here, or the pressure reading. So we're at 0.5. If we want to go to a higher pressure, you merely open these up a little bit more. You notice that the bubble in the middle, or the ball in the middle, will actually increase, so we're going up to a higher pressure range right here. So that's how you control the pressure in your chamber, by the flow of gas going into the chamber. This is, once again, is your timer. Always want to check your timer to make sure you have plenty of time. And once again, you notice the indicator lights over here, which are very helpful to let us know what stage the system is in. So once again, I'm going to go ahead and abort the process, and you can see what the system can do. Thank you very much for your interest in the Glow Research OptiGlow ACE system that's used for ashing, cleaning, etching, and various other plasma processes. So this concludes the presentation on the Glow Research OptiGlow ACE system. Thank you very much for your interest. If you have any questions, please feel free to call us at this number right here, or you can contact us at glowresearch.org. Thank you.